Hi everyone. In this video, we are discussing the second exercise of first chapter, that is exercise 1.2 of NCERT Mathematics textbook of class 10. Let's go through the first question. First question is to express a few set of numbers as a product of its prime factors. So one number among them is solved here. Let's consider this number 5005. We have to express this number as a product of its prime factors. So that I am factorizing this number. In order to factorize this number, I am writing this number and I am choosing one of its prime factors. That is, obviously this number is divisible with 5. So that I am writing 5 here and I am writing 1 times 5, then 0, 0, putting the zeros down, then 1. Okay. Then this number is divisible with 11. So 9 11s are 99 in 100 and remaining is 11, 1 11. Okay. Then next 91 is divisible by 7. So 1 7 is there in 9 and remaining is, as we considering 21, 3 7s are 21. So 13 is prime number, so we stop there. And we can write the prime factorization of 5005 as 5005 is equal to 5 into 11 into 7 into 30. If you want to draw the factor tree of this number, we can draw the factor tree as first we are writing this number 5005 in a circle. Next, uh, one branch there is 5 and in another branch 1001. And this number 1001 have two branches. One of its factor is 11 is a factor and 91 is also a factor. And 91 also have two branches, that is 7 and next branch is 30. So this is a factor tree of the number 5005. Let's consider the second question. Second question is to find the LCM and HCF of the following pairs of integers and verify that LCM into HCF is equal to product of the two numbers. The given two numbers are 26 and 91. We have to find HCF and LCM of these two numbers and verify this result. The result is given as LCM into HCF is equal to product of two numbers. For that, first of all, obviously we want to find the LCM and HCF of both of these numbers. Let's write a number. Let's first of all we can use prime factorization method. Okay, or using the fundamental theorem of arithmetic. Okay, I am factorizing 26. I will get 2 times 30. And if I am factorizing 91, I will get 7 13. And I can write the prime factorization of these two numbers as 26 is equal to 2 times 13 and 91 is equal to 7 times 13. And I can write the HCF of these numbers as highest common factor here and there. We can find the highest common factor here and there is 13. So 13 is the HCF. And LCM of these two numbers is I am taking the highest power of each factor among these two factorizations. So that I can write the LCM as 2 times 7 times 13. And I will get the LCM of 182. Next, I want to find LCM into HCF. If I find LCM into HCF, I have to multiply 182 into 13. And second, what I have to do is that find the product of two numbers. So product of two numbers, the two numbers are 26 and 91. So 26 and 91 are the numbers. So that I have to multiply these two numbers. So I will get common answer. I will get the product as 2366. So that I can conclude that LCM into HCF is equal to product of two numbers. Let's come to the next question. Find the LCM and HCF of the following integers by applying the prime factorization method. So the method of finding LCM and HCF also mentioned here. So that we are using that method of prime factorization. So that first of all we are prime factorizing all of this, each of these numbers. 12 is equal to 2 times 6, 2 times 3. And again written as 12 is equal to 2 times 2 times 3. And 15 is equal to 3 times 5. And 21 is equal to 3 times 7. So that I am writing all this prime factorization as 15 is equal to 3 times 5 and 21 is equal to 3 times 7. In next step, I will get the HCF of these three numbers as HCF of 12, 15 and 21 is equal to the highest common among all these three numbers. So the highest common is 3 is common. So I will get the HCF is equal to 3. And for finding LCM of 12, 15 and 21, I am taking the maximum power of each of these numbers. Okay, so first of all, I am checking the maximum power of 2. 2 is 2 times 2 into 2 or 2 raised to 2. That means I have to this option 2 square. Next, for 3, the maximum repetition of 3 is only 1 times. So 1 times 3 also I have chosen. Next, I am considering 5. 5 also 1 times and 7 also 1 times. So multiplying all these numbers, I will get LCM of these three numbers. So I will get LCM of these three numbers of 420. Next question is to find LCM and HCF of 17, 23 and 29. Here we can see that all these three numbers are already prime numbers. So prime factorization of 17 and 17 can be written as 1 into 17. There is no, in particular, there is no prime factorization. 17 itself is a prime number. Similar for 23 and 29 also. So that we can write the HCF of co-prime numbers. So HCF of 17, 23 and 29. These are co-prime numbers. In particular, they are prime as well. So their HCF is 1. And the LCM of these three numbers are 17, 23 and 29. So that is equal to 17 into 23 into 29. So here you have a common result. HCF of co-prime numbers is always 1 because they are co-prime means there is no common factor other than 1. So highest common factor is also 1. Similarly, we can say that the LCM of co-prime numbers is always the product of numbers. And if you are multiplying all these values, you will get the LCM of these three numbers of 1139. Let's consider next question. Given that HCF of 306 and 657 is equal to 9, we have to find the LCM of 306 and 657. Here the result we are using is that LCM into HCF is equal to product of the numbers. When two numbers are there, their LCM and HCF will give the product. The product of their LCM and HCF will be same as the product of numbers. So here the numbers also visible for us. The numbers are 306 and 657, and HCF is also given. So we can put the value of HCF here, and we can rewrite the statement as LCM into, instead of HCF I am writing 9. 9 is equal to product of numbers is not given, but we can find out. 306 into 657. And from here we can rearrange this and find out an expression for finding LCM. LCM is equal to 306 into 657 all divided by 9. And after solving all this, you will get the final answer as 22,338. That is a LCM of these two numbers. Next question is to check whether 6 raised to n can end with the digit 0 for any natural number n. Here the given expression is 6 raised to n, 6 with the power n. N can be any natural number. So the answer of this statement or this expression for any natural number n, whether this will end with end with a digit 0. This is a question. So how to find out this? Here for find out this, we can consider the number 6. 6 can be written as 2 times 3, and the power of this will be 6 raised to n is 2 times 3 all power n. So this is 2 raised to n into 3 raised to n only. So as per the fundamental theorem of arithmetic, we can say that a number can uniquely express as product of its prime factors. So this representation or the prime factorization is unique. For being 0 in one's place, the condition is that it must be a multiple of 10. In particular, it must be multiple of 5. So this is 6 raised to n. This expression will not be a multiple of 5. Therefore, we can say that this is not possible. Next question is to explain why this expression 7 into 11 into 13 plus 13, and the second expression 7 into 6 into 5 into 4 into 3 into 2 into 1 plus 5 are composite numbers. Here we have to show these two are composite numbers. Composite numbers, to show these are composite numbers, we have to show some property of composite number. That means we have to show some factors of this number, some prime factors. So every composite number can be expressed as a product of its prime factors. So then we have to express this number as product of its prime factors. But here this expression is not in product form, because here in first expression 7 into 11 into 13, this much is okay, but the last 10 is plus 13. A 13 is added here. We have to rearrange this and make it a product form of prime factors. So first of all, consider this and let's try to rearrange this and make it as product of prime factors. So that first I am writing this 13 is here and there. I am taking the 13 common outside. So 7 into 11 into 1, or this 1 is not required. 7 into 11 into 1 plus 1. And taking this 13 outside. In next step, I am rearranging this as 7 into 11 plus 1 into 13. Next, I am applying the BODMAS rule. First of all, I am solving whatever I am seeing inside bracket. So I am multiplying this 7 into 11. I will get 77 plus 1 into 30. So I will get 78 into 30. Now I can factorize this 78 as 2 times 39. So then I can write the 78 as 2 times 3 into 30, and this last 30 also there. So that I can write this first expression as 2 times 3 times 13 square. So this is a product of prime numbers, product of prime factors. So that I can say that this is a composite number because it can be expressed as product of its prime factors. Let's consider the second question. Second question is given as 7 into 6 into 5 into 4 into 3 into 2 into 1 plus 5. Express y or express this as prime factors, and then we can show this as a composite number. So first of all, what we have to do? First of all, we are making a rearrangement. Here we can find that 5 is a common term there. I can take this both these 5's outside, and I can rewrite this as 7 into 6 into 4 into 3 into 2 into 1. Okay, 1 is also there, plus 1. Both of these 5's outside and writing like this. Next, I am solving whatever I am saying inside bracket. I will get 1009, and I can write it's a product with 5. Now it's a form of product of prime factors. So that I can say that this first expression is obviously a composite number.